Do it last period. All right, so here we go. Modeling and exponentials. Like I said, these is easy. First of all, we'll start off by determining the type of function. There's really going to be three types that we're looking at. Either A, to go from one y to the next, they're multiplying, which means it'll be an exponential. Or you're adding, which means it'll be linear. Now, if it's adding for two layers, and we'll tell you what that means in a minute, it'll be quadratic. All right, and those are the three types we're talking about today. Exponential, linear, quadratic. So here's what I mean. Basically, what are you doing to go from one y value to the next? And to see if we're multiplying, we're just going to back it up and divide. So what is 1 divided by 0.5?
1 divided by 0.5?
Don't pull out a calculator for that, please. What's 1 divided by 0.5? How many 0.5s go into 1? 2. Okay, there we go. All right, so we multiplied by 2 to go up that level. What's 2 divided by 1?
1.
What's 2 divided by 1?
2.
2. What's 4 divided by 2? What's 8 divided by 4? What's 16 divided by 8? What's 32 divided by 16? You sure? Yeah, it's 2. All right. So each time, each step multiplies by 2. I just used the divide to figure it out. I just looked at it backwards. So it's what? Exponential, linear, quadratic? Linear. It's exponential.
What?
Are we adding to go from one step to the next, or are we multiplying?
They're multiplying.
N-E-N-T-I-A. Wow, my pen just does not want to write. Whatever. All right, letter B, same idea. You can look at the x's and say, well, we're going up by 2s, and that's okay. They're consistent each time they're going up 2. So long as they're consistent, that's what we care about. So let's try dividing first. Let's see if it's exponential. What is 0 divided by 2?
0.
0. Okay, what's 2 divided by 0?
0.
No. What's anything divided by 0? Yeah, no, it just straight up does not exist. Can you divide by 0?
No.
No. Okay, what's 8 divided by 2?
4.
Okay, so hopefully you can tell right now, is this exponential? No. Okay, so let's forget that. Let's see if we're adding instead. So to go from 2 to 0, we're subtracting 2. To go from 0 to 2, what are you doing? Adding 2. 2 to 8, you are? Plus 4. And actually plus 6. To go from 8 to 16, that's a plus. That's a plus 12. If you can't see it offhand, do it the other way and subtract. You can think 28 minus 16 instead. You can think, if you can't see it forwards, try doing it backwards. So like 44 minus 28, what's 14 minus 8? What's 14 minus 8? 6. So that makes this a 3. What's 3 minus 2? 1. That's 16. All right, so is it linear?
Linear, yes.
Are those okay, hold up. Is that going up by, are those the same? No, therefore it is not linear. So let's try it again. What do we go, from negative 2 to positive 2, how much are you going up?
4.
You're going up 4. From 2 to 6, you're going up?
4.
From 6 to 8, you're only going up 2. But 8 to 12, you're back to the 12 to 16, they're going to. Now, I will admit, I honestly think this 2 right here is just a straight up typo. It was not intended to be there. All right? This is supposed to be all 4s for the purposes of the exercise. So ignore it for the moment. On your homework, don't ignore it. But for right now, ignore it. All right? So the second set of differences is the same. So which is it?
Linear.
No.
We've said no to linear for 5 minutes, dude. It's quadratic. Okay, no, here we go. Did we add the same thing every time we went up?
No.
2 plus what is 0? These are the same every single time?
So what is the plus?
No, they are not. Okay, straight up. You're telling me 2 plus something to get to 0 is the same thing as 2 to 8, is the same thing as 8 to 16, is the same thing as 16 to 28? Is that the same gap? No. It is not linear.
I was looking at the top one. It's going up by 2 every time. You know,
You're fired.
It's been fired.
I love you, dude. Well, at least you figured it out. All right, Cole. We're looking at the y's. All right, so this is quadratic. because the second difference is the same. All right, you're right. The x's have to be consistent. If the x's aren't consistent, then it doesn't matter what the y's are. All right. So here we go. Here's what I want you to do. Letter C. Knock it out real quick. Tell me if it's quadratic, linear, or exponential.
It's linear.
Finally. All right. Well, what is it?
Linear.
Why?
Because you subtract it by 3.
You're subtracting 3 every time. So that's a minus 3. That's a minus 3. So the very first difference is the same. So it's linear. Okay? Try letter D. Don't yell it out. Do not yell it out. Let everybody figure it out. And how about you actually get something to write on, so you can remember it past next year? I'm serious, dude.
Oh, this is. You said not to say that out loud. One, Chris.
All right, which is it? Linear, quadratic, or exponential?
Exponential.
Exponential, good. What's the difference each time?
Multiply by 3.
We're multiplying by 3? So 27 times 3 is 9? We're dividing by 3. We're actually multiplying by a third, technically. So it's exponential.
I did it backwards. Can you do it backwards? That's what they say?
If you did it backwards, you need to divide. So 9 divided by 27.
Like I did it from the front. You did it from the front.
Well, that's fine. If you multiply by 3 to go this way,
Yeah.
and you divide by 3 to go the other way.
But it's the same thing.
No, it's not.
It's not.
It's not, because the equation going this direction is different from the equation going that direction. You
But
follow me on
it
that?
would end up the same. Like, it would. Chris.
He's talking about if you did 27 divided by 9,
My point is
and
this.
divided by 3.
What you said is, okay, so I multiplied by 3 to go up every step. We're not asking, what are you doing to go down the scale like this? We're asking, what are you doing to go up the scale? Yes, they're exponential. You're absolutely right. But one will lead to a different equation than the other. You follow me on that? So think of it as going to the right, okay? You're right. All right, here we go. So that's that. The rest of this is writing equations, okay? And this is actually quite easy. What we're going to do is we're going to build a system and solve it using substitution. It's actually very simple, okay? It says write an exponential model that passes through the given points. So your model in this case is y equals ab to the x. That's your baseline form of an exponential. You just need to find out what a, b, and are, okay? So what we'll do is we'll create 2 equations, one for each point. So the first one is 1, 6. So for y, I'm going to put a 6. A, b, and then for x, we'll put a 1. Cool? For your other equation, what are we going to plug in for y?
Well, I'm plugging in 54.
Equals a, b to the what?
Third.
Third. All right? Everybody cool with that so far?
I ain't cool.
Seriously? It's okay if you're not. Are we cool? All right, cool. From here, start off by solving for a first. Yes, you can solve for b first. It will work, but it's a little more difficult. So I'm going to start off by solving for a. So if I want this a right here, what do I need to get rid of?
Divide by b.
Divide by b. So it's literally 6 over b equals a. Cool?
To the 1.
It's understood. So there's always a 1 there, no matter what. From here, we solve for a, and we'll plug it in over there.
So it'll be a squared.
54 equals 6 over b, b to the third. We are swapping it out. We know a is 6 over b, so it's kind of like you give me a 20, I give you 4 5s. Follow me? Same idea. And then solve for b. So what's b to the third divided by b? What's b to the third divided by b?
Just 3.
That'll be b squared.
B squared. Just subtract your exponents. 3 minus 1 is 2. Okay, where are you going to go from there?
You got, back 6.
The 6 adding? Divide by 6. So what's 54 divided by 6? What's 54 divided by 6? 9. Okay, where are you going to go from there?
You got a root.
Square root it. So what's the square root of 9?
3.
3. Now, technically, it's plus or minus 3 because the squared. But your b is your base up here. You can never have a negative base. So we don't care about the negative side. Cool?
So 3 equals B.
B is 3.
That seems easy.
It is easy. Now that we got B, how do you find A?
Plug it in.
Does it matter which one you plug it into?
No.
So how about this one right here?
Plug it in.
So what's 6 divided by B? 2.
2 equals A?
Yep. So 6 over 3 is A. So that's 2. So they want you to write the equation. Here's your equation. Y equals 2 times 3 to the x. That's the equation. That goes through those. That's the equation of the point. The equation that goes through those 2 points. All right. So here's the deal. If you want kind of steps or goals, think of it this way. Your goal 1 is write equations. Step 2 would be solve for A and plug in. All right, and the process might be slightly differently depending on what you do, but it's going to be very similar. 3 is find B and go. So the reason I say that is once you get to this point right here, I'm pretty sure you can get the rest on your own without thinking too hard about it. You follow me? Even if it's not this obvious, you know where to go with it. You follow me? Cool? All right, let's do another one. 2 letter B. All right, let's start here. Start off by, if you want to finish it, that's fine. Start off by writing your equations. Write your equations for letter B. Take 10 seconds. You can do it in 4.
I can do it in 1.
I don't know about 1. I don't think you can write that quickly.
I don't either. Alright, I'm going to start.
Which I'll write it in brown just so we stay consistent. Because it's y equals ab to the x. X is
You have to take out your X and your Y.
1. Which, here's the deal. You don't have to write the 1 because it's understood. I'm just writing it to make sure everyone's following along. Cool? All right, so from here, let's solve for A. Which A do you want, the blue one or the red one? I would go with the blue one. Go with the smaller exponent. So solve for A and plug in the other equation. Solve for A and plug in the other equation. Take, I don't know, 20 seconds.
I got it. I went all
You
the
cool
way.
with that?
I went all the way.
All right, if you're good with that, finish it out.
It's 5, right?
Huh?
It's 5, right?
I think it's like 5 and 2 or something like that.
That's what I got.
You got 5?
Yeah.
For A.
Yeah, yeah. That's what I'm wrong. I do know stuff. I'm an ace of steps.
Good. Cool?
Where you get Oh, you plugged in A.
Cool. Good. Yes, is exactly what I did.
Yeah, I got it.
Plugged in B. Good. So how are we doing this? Give me 5 to 1. 5, I got this. 4 I'm okay. 3 and 2 I'm less. Sweet. All right, turn the page. Whenever you're done writing, turn the page. We're going to skip letter C because we've already done 2 where you have an x value of 1. Okay, we've already done 2 where you have an x value of 2. We're going to do one where we'll do one where you don't, which honestly it's not any harder, it's just different. I don't want you to freak out at a few spots, that's all. So letter D. Start off by writing your equations. Write your 2 equations. Cool?
Yeah.
We good with that? All right, and then we'll solve for A. You can do either one, but which one do you think would be better, the blue one or the red one? I would do the blue one again. Again, stick with the one with the smaller exponent. It typically comes out easier. All right, so all you got to do is divide by b squared, and you're left with this. Don't let the squared freak you out. There's nothing to reduce. Just leave it like that. Cool? And then plug it into the other side. All right? I mean, if it's a b to the 4th, just put a b to the 4th on bottom. That's all you got. There's nothing different. So we got 24 equals 12 over b squared times b to the 3rd. So we still cool. Anybody having trouble pulling this? What's b to the 3rd divided by b squared?
Big B.
Just a b. Good. 24 equals 12b. So b must equal 2. Okay, last bit. Plug that sucker in. What's 2 squared? 4.
3.
What's 12 divided by 4?
3. What? 4?
3. So your equation is y equals, do you put the 2 first or the 3 first?
3.
Good. 3 times 2 to the x. I told you it was easy. Man, I wanted to do this one simply because it had this sucker, because there's enough people that would freak out about it. And I didn't want you to forget when you plugged it back in, you got to square it. That really is the only thing. Are we still doing okay?
Let's go to the back.
Let's do one more problem. We're going to do one more problem. We're done. We're not going to do the rest of it.
Oh, okay.
Because the homework didn't show up on it, nothing like that. So we're going to do one more problem. We're done.
Yeah.
Here we go. A store sells trampolines. The table shows the numbers y of trampolines shown in the next year. Trampolines. So basically, in year 1, how many trampolines do they sell? What about year 4? 36. Good. All right. Write a function to model the data. Write a function that models the data. Do you think this model can be used to predict the number of trampolines? Okay. So we're going to write an exponential model. Okay. You can use any 2 points you want.
Let's do 1 and 12 and 2 and 6.
Yeah. You could use
26.
5 and 7. You could use 3 and 7. Use 1 and 2. For crying out loud. Don't make it harder than it has to be.
I feel like 4 and 36 would be easier.
4 and 36.
1 and 12.
Let's use these 2 right there. So those are your 2 points. I mean, honestly, it's not that one's really harder than the other, just the numbers get bigger. All right? So write your equations out. And go.
Y equals
Y equals ab to the x. That's your base function. Y equals ab to the x. See if you can do it without using a calculator.
I can do that.
I know you can. You might hit a snag, but I don't know. We'll see. See if you can pull it off. Yeah. You can do it. You can do it in your head still, trust me. Let's just leave it as 4/3. I trust. Well, what's 16 divided by 12?
Yeah.
Reduces down to 4/3. Just leave it as a fraction.
Oh.
Cool. And this is the part where I think people may give up.
I got some names.
12 divided by 4/3 equals A. It is 9. Here's how to do it in your head. Remember fractions, the top part multiplies and the bottom part divides, right?
Yeah.
Yeah, but we put in the denominator, that means the top part divides and the bottom part multiplies. So just shove the 3 up there. 12 times 3 is what? What's 36 divided by 4? 9. So essentially what you've got is 12 times 3 over 4, which is 9. Cool.
So y equals 9, 4 over 2.
Yep, 9 parentheses 4/3 to the x. At least it's part of the test. All right, last bit. It says, do you think this model can be used to predict the number of trampolines sold in the 15th year? Now, here's the deal.
Yes.
Remember, this equation, they go like this. They go here. You remember they start going up really quick? You know that? So it's going to get really high really fast. So take a second. Plug in 15 for x real quick. Just take a calculator. 9 parentheses, 4 divided by 3, close parentheses, to the 15th. And what do you get? 673. Do you think a store that has been selling less than 100 for 7 years straight is all of a sudden going to jump up to 600 something? Probably not. So the answer in this case is no.
No. Big fat no.
I'm going to say no because exponentials get real big,
Why, Chris?
real fast. They head to infinity very quickly. So here's the deal. It might be accurate in the lower regions, but as it goes to infinity, it's going to be way off. All right, and that's what we got.
Chris, you will.
So, pull out a book.